I'm going to call lambda 1 cosine of theta plus I sine of theta, and lambda 2 to be cosine of theta minus I sine of theta. Well, in this case, we note that lambda 1 is the conjugate of lambda 2. And well, let's see. Let's see how we can use this and find the associated eigenvectors. So I'm going to pick the first one. So let's find the eigenvectors of the matrix that I'm going to call now A, associated with lambda 1. So in this case, well, I want to find solutions to the following equation. So let's find non-zero solutions to A minus lambda 1I times V equal to 0, the zero vectors, right? Okay, well, let's expand this. What does this mean? Well, I have to rely on this Gaussian elimination as usual to determine a basis for a null space associated with this equation. So in this case, we will have the following. The following matrix, augmented matrix. So we'll have I negative sine theta. I'm subtracting, remember, I'm substituting here. On the other one, I will have I sine theta for this one. Over here, that remains the same, so we'll have negative sine theta. For this one, well, I'm subtracting, so I will have cosine gets cancelled, and this one becomes negative I sine theta. So, well, I'm expanding over here. So, well, if we go over the assumption, let's say that sine theta is different from 0, which is really the only interesting case for the complex situation. Because if theta is sine of theta is equal to 0, then this reduces to the identity matrix, and well, and that contains only one eigenvalue, namely 1. So that case is already covered. The one that we want to stress out is on this one. So let's say that this is different from 0, so I'm allowed to divide everywhere and row by row to obtain the following reduced matrix: negative I, 1, negative 1, negative I, 0, 0. Now, if I multiply this row by I will get the following. Let me multiply this by I row 1. So it's the same type of operations, but now involving complex numbers. So this becomes, well, I times I is negative 1 times negative, it becomes 1. I, expand it over here, negative 1, negative I, 0, 0. Now, well, I'm going to add the result, in this case, of row 2 plus row 1, and, well, I modify the matrix, so I have that remains unchanged, this becomes 0, this becomes 0, this becomes 0. Oh, well, what is this saying? This says that the vectors that I have associated here, if I have x1 and x2, well,